What the heck just happened? Come on. Get on there. Thank you. Alright, here we go, guys. Perpendicular bisector, okay, is this guy. If it's a bisector, it cuts it in half. Okay? If it cuts it in half and it's perpendicular, that means we have this is equal to this and these two are 90 degrees. The other thing about a perpendicular bisector is that these hypotenuses that it creates, because these angles are the same, these sides are the same. Okay, that's really what happens. It's all about proportion. Alright? So since we know this, and think about it, we know that these two are congruent. We know that these two are congruent. We know that these two are congruent. So we have angle, side, side. Okay? So if we have angle, side, side, and we know that the triangle is right, okay, then we know that the two triangles are congruent. Does that make sense? So that means that this angle is congruent to this angle, that this angle is congruent to this angle, and that this side is congruent to that side. And that's huge. Because then we can do pretty much anything we want. Okay? And this goes backwards and forwards. If we know that these two sides are congruent, then we know that this is a perpendicular bisector. Okay? Same thing if I have an angle bisector. If I have an angle bisector, then any point on that angle bisector creates a perpendicular with the other two lines, and those two are going to be congruent. So let's think about that. These two angles are congruent. These two sides are congruent. And these two angles are congruent. So what do we have there? We have angle, angle, side. So if we have angle, angle, side, we know that the triangles are congruent, right? That means everything else is congruent. That means this is congruent to this. That means this is congruent to this. That means this is congruent to itself. Does that make sense? Okay? That's huge. Okay? So in problem number 14, remember, all this goes backwards and forwards. Remember? These are what we call biconditional proofs. All theorems go backwards and forwards, and that's why they're called theorems. Okay? Instead of postulates. Postulates go one way. Theorems go both ways. Okay? So, when they tell us that we have J, G, and GK, and they tell us that those are congruent, right? Because 70.2 equals 70.2, right? That means that these two are congruent, right? So our first step here is given. GJ is congruent to GK, right? And that's our first step. That's given. Alright? What does that mean? So which one is that? Is that this guy or this guy? See what I mean? Because we don't know any of this right now. All we know is what it told us. And all we know is that these are congruent. And if we look, which one of these has the hypotenuses are congruent? Right? And what does that mean? It means that it has to be a perpendicular bisector. If these two sides are congruent, then that means that this has to be a right angle, okay? And this has to be congruent. So in other words, this line T is a perpendicular bisector. And that is the converse, right? The converse of a definition of a perpendicular bisector, which means it's going backwards. It's saying, hey, since I know those sides are equal, I know this has to be perpendicular. Now from that, do we know anything? And we know a lot. We know that I'm not doing roll. So, yeah. Okay, so we know that we have a side, and an angle. And we know we have an angle, a side, and a side. So what do we know? From chapter 4. Which triangle theorem is that? Not side, angle, side. Remember, to say side, angle, side, that means I went side, angle, and I skipped over the side and I skipped over the angle. I can't skip over two things, right? I have to go to the next thing, either the next side or the next angle. Does that make sense? So I could go side, skip over this and go to side, right? That's legal. And then go to angle, which is side, side, angle. What does that look like? What? What does it look like? Ass cheeks. Yes. Angle, side, side, but backwards. Okay? It's like looking at yourself in the mirror. Trying to see if they sit on that glue. Okay. So, angle, side, side. Does angle, side, side work? When does it work? When it's right. Is it right? Yes. Because it's a perpendicular bisector, we know that these two triangles, that triangle, what triangle? How do you want to say it? GHJ, HGJ, I don't care. How do you want to say it? JHG? Okay. So we're going to say JHG. Now we care. This next one matters. If we're going to say JHG, then we have to say this other one in a specific manner. What manner is that? Huh? Speak up, come on. Look. I'm going from here to here to here. Now what am I going to do? Does that mean I go here to here to here? Here to here to here? Here to here to here? What am I going to do? Yeah, here to here to here. Think. What does this side have to do? Is it? KHG, yes. J and K are kind of the mirrors of each other, right? H is itself, G is itself. So if I'm doing this, that means I have to do this. Does that make sense? So that means I have to go KHG. KHG. That is the hardest part to this. Okay? Knowing which way I'm going. Now, I know that that's true because of angle, side, side. And I know that the triangle is right. So I know it's true. Now here's the gorgeous part. And we didn't work on this a lot last semester. But that's why I'm putting it hard this semester. Okay? This next one. Let's do it. That means that this is congruent to that. That angle J is congruent to angle K, right? What else does it mean? That angle HGK, right? Angle HGK is congruent to what angle? HGK, HGJ. Good. H, G, J. Right? So I can say this. But I don't want these to all have 1. So since it's a second one, I got to put 2 lines. Does that make sense? 2 arcs. Okay? Alright. What else do I know? So I know these are congruent. 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 And one last thing. This. Right? Now remember, since I came up with these have to have 2 pieces also. This has 1 and these have to have 2. And that's why I put 3 here, okay? Because they're not congruent to each other, right? So therefore, that's why they're different. 3, 2, 1. Okay? Now, what that means is that GH is congruent to GH. Okay? Now, why can we say all of that? And after, well, yeah, this is reflection, but we can say all of this because of one rule. One rule lets us say it all. Once we say that the triangles are congruent, we can say all of these other things because CPCTC. What the heck is that? Do you remember that? I know, I said it wrong last semester. You're right. The way I told you was congruent parts of congruent triangles are congruent. I was wrong. It's corresponding parts of congruent triangles are congruent. Okay? So it's corresponding, meaning the parts that are corresponding to the other parts. Parts of congruent triangles are congruent. Okay? So corresponding parts of congruent triangles are congruent. CPCTC. This is a huge rule or theorem. Okay? So now we can say anything we want. Almost. What do I mean by that? What I mean by that is, look up here at JH. Where is JH? That's right here, right? Because we know that everything is congruent to its corresponding parts, that means that its corresponding parts have to be congruent, right? And if they're asking us about HK, then HK is congruent to JH. Right? Because we already said that, right? Up here. We actually didn't have to go through all this to get to that. The reason I went through it all is because if they ask you any other thing, if they asked you what angle K was, right? Because they gave you angle J, I would know what it is. If angle J is 50, then angle K is 50. If they're 50 and this is 90, what does this one have to be? 40, right? Because these are complementary. Okay? That's how this is going to work. We're going to use everything we used all this semester to figure out what we're going to do. So in 14, they ask you, find JK. Oh, they want to know what JK is. Okay. Well, I know that this is 26.5 and this is 26.5, right? And I know this. Why do I know this? Because of that, right? CPCTC. Then what? Then this is what? What do we call this when we plug it in?
Substitution.
There. Okay. Then how do I know what HJ or Yeah, HJ is, or KJ is. So what's KJ? You just add these up. You just add those two pieces up, right? If we're talking about this whole piece, we're just going to add these two pieces. So that's 26.5 plus 26.5, which is how much? 53. And that's 14, okay? There's a lot to that, okay? So the homework